Good morning, everyone. Am I audible? Am I audible? Can you hear my voice? Please mention in the chat box. Okay. Okay. So let us start. Okay. So last class we have discussed about your trickling filter, right? Okay. Just give me a minute. Okay. So last class we were discussing about the trickling filter part. So I think we have completed that. Okay, so we have learned about the trickling filter process. So today, okay, that day I told that there were two processes for your filtration. Like one is your under your biological treatment, there are two processes, two types of filters. One is your trickling filter, in which the biomass or the organic matter, microorganisms, those are attached in the filter media, and one is your suspended. Okay, the other one is your same, it is a secondary treatment process itself, but here what happens, the that aerobic bacteria or the bacteria or the biomass, it is suspended in nature. Okay, so let us see what is activated sludge process. Okay, so here you see the activated this sludge, in the activated sludge process, the sewage effluent, okay, the effluent that comes from the primary sedimentation tank, okay, that effluent, it is utilized in this process, okay, and it is mixed with 20 to 30% of its own activated sludge. Okay, so like it is mixed with 20 to 30% of its own volume of its activated sludge. Okay, and then this activated after it is mixed with its own volume of activated sludge, then it contains a very high concentration of what, active aerobic microorganisms. Okay, this activated sludge, it contains aerobic microorganisms. Okay, then after the mixture, I mean the sewage effluent from the sedimentation tank and the this activated sludge is mixed. Okay, then this mixture, it enters the a tank. Okay, and that tank is known as your aeration tank. Okay, so that mixture, it enters the aeration tank, where in that aeration tank the microorganisms and the sewage, okay, the sewage effluent, those are mixed very nicely. Okay, those are mixed very thoroughly, and in the presence of what, air. Okay, in the presence of air, and for you can say for like 4 to 8 hours, those mixture, that mixture is mixed in presence of air. Okay, so under that condition, what happens that the moving organisms, okay, the moving organisms means what? The organisms, okay, coated around the sludge solids, okay, so they kept on moving because of that mixing or agitation, you can say. So these organisms, they will oxidize the organic matter. Okay, so when it is mixed, when the sewage effluent and the your activated sludge is mixed in presence of air, so what happens? The organisms, they will move, they will oxidize the organic matter, and the suspended and the colloidal matter, they tend to coagulate and they form a precipitate. Okay, so the suspended and the colloidal matter, they due to that mixture, due to that intimately mixing, so what happens? The suspended and the colloidal matter, they coagulate with each other and they form a precipitate. So when they form a precipitate, they settles down very easily, okay, in the secondary settling tank. So there is a settling tank, secondary settling tank. So in the tank, the this precipitate, it easily, readily or easily, it settles down in the settling tank. Okay, so now after it settles down, so that settled sludge, it is known as your what? Activated sludge. Okay, so that settled sludge is known as your activated sludge. And then what happens when that activated sludge is formed? A part of that activated sludge is, like, it is recycled. Okay, it is recycled up, half part of this recycled, and it is taken back to the aeration tank. It is again taken back to the aeration tank, and again then it is again mixed with the sewage after being treated. Okay, and that again the same process is continues, and then again a part of the activated sludge, it is disposed of. Okay, it is disposed of properly. Along with the sludge, it is collected during the primary treatment. Okay, so I want to show you one video. Okay, whose mic is on? Please mute your mic. Roll number 79, parting. Mute your mic. Okay. So this process, activated sludge process, I want to first show you one video. First, you understand. Actually, if I tell you like this, you will not get the idea of what is an activated sludge process. So let me show you one video. You see the video and then you understand. Okay. Then after that, I will again explain. This mic is constant.
Hey guys, real quick, let me give you a tip on an amazing Black Friday deal. Right now, Udemy courses.
Activated sludge is worldwide the most used suspended growth process in wastewater treatment. The treatment process can include different steps, but most commonly are screening and grit removal to filter out debris, primary clarifier for particle sedimentation, biological treatment with activated sludge consisting of an aeration basin, secondary clarifier, cycle stream, disinfection for final removal of germs and bacteria. Wastewater entering the aeration basin still contains organic matter such as food waste and fecal. Microorganisms in the raw water influent will colonize in the aeration tank and metabolize organic waste to ATP for further cell growth, as well as CO2 and water. As the microorganisms need oxygen to survive, the tank is aerated, for example, with diffuser systems. The amount of oxygen needed for biochemical processes is also known as the BOD value. BOD is a very important indicator for the level of wastewater pollution. To keep a good balance between the number of microorganisms, organic waste, and oxygen, some microorganisms are settled down in the secondary clarifier. Adding flocculants will cause that microorganisms will clump together with particles and settle down as activated sludge. Some of the activated sludge is then recycled back to the aeration basin, whereas the rest is removed as waste sludge, thickened, and then, for example, used as fertilizers. By recycling the activated sludge back into the aeration basin, the amount of microorganisms can be increased significantly, e.g. 30 times compared to the raw water influent. This is exactly the principle of activated sludge, to accelerate biological degradation significantly in a confined space. The sludge recycling rate does not only affect the sludge volume, but also the sludge age. Young sludge, 2 to 8 days, refers to microorganisms that metabolize organic waste as described before. Instead, older sludge, older than 8 days, is used for nitrification processes to oxidize ammonium, NH4+, to nitrate, NO3-. The sludge age can also be expressed as the SRT, solid retention time. The SRT is the volume of the reactor multiplied with the concentration of solids divided by the excess sludge. The number of microorganisms present in the aeration basin, and therefore the treatment capacity of an activated sludge plant, is limited. The ratio of microorganisms and waste stream is also known as the MLSS, mixed liquor suspended solids concentration. As higher the MLSS, as less volume is needed to remove BOD from the waste stream. The maximum MLSS concentration for activated sludge basins is about 3,500 milligrams per litre. However, by adding fixed film media into the aeration basin, also known as IFAS systems, the MLSS can be increased by up to 5,000 milligrams per litre, meaning the treatment performance can be increased by up to 50%. Please click on the following video link to see in detail how the activated sludge process can be upgraded with fixed film media systems. Thanks for watching, and if you like our 3-minute tutorials, please subscribe and don't forget to give a thumbs up.
Okay. So you have seen the video, okay? So now I think you can imagine, you can somewhat understand what process is going on there, okay? So whatever I told here is explained in that video, okay? So now, the here, the affluent, okay, you see this line, the affluent, let me annotate it here. The effluent obtained from a properly operated activated sludge is of high quality. Okay, so the effluent, the effluent that you get from your activated sludge process or a sludge plant, it is of very high quality, and also it has a very low BOD than that of a what trickling filter plant. Okay, so this might be, you can say, if this is a difference also you can say between your activated sludge plant and your trickling filter plant. So and here the BOD, the removal of BOD is up to what 80 to 95%, and bacteria removal is up to your 90 to 95%. So that you can see here that this process, the bacteria removal is up to 90 to 95. That means it is a very good process, isn't it? It is a very good process of removing your bacteria and your removal of your BOD. So here again the land area, okay, for the the activated sludge treatment plant, here the land area required is also very less, okay, it require a very small area, and in this process your a very huge amount of oxygen is also required, okay. So here there are some like they have given some you see this line that but however in this process a rather close degree of control is necessary in operation to ensure here like you a degree of control, or you can say that the here some control is required in its operation because of what, because to ensure that there is an ample supply of oxygen is present, okay, there should be ample supply of oxygen. Then again, there is intimate and continuous mixing of the sewage and the activated sludge. So in that process where we have studied that, like here the effluent from the primary sedimentation tank and the activated sludge is mixed properly. So this is also needs some control. Okay, so it should go on nicely. Then the ratio of the volume of the activated sludge added to the volume of sewage being treated is kept practically constant. So the ratio, the ratio of how much of activated sludge you have added and how whatever volume of sewage is being treated, it is kept constant. Okay, then okay, next. So there are like some what I will say. Wait. So there are some methods of aeration. Okay, some aeration tank is there. We have studied about the aeration tank. So their aeration tank of an activated sludge. Okay, so that is your like there are different methods. Okay, but before going to the methods, you see the sewage from the sewage effluent from the primary sedimentation tank, it goes to the aeration tank, isn't it? So in that aeration tank, and it is mixed with the activated sludge. So in that aeration tank, the mixing is done. So here the aeration tanks, they are normally what? Rectangular in shape. Okay, they are rectangular in shape and they are 3 to 4.5 meter deep. Okay, and they are also 4 to 6 meter wide. So what is their depth? It is 3.43 to 4.5, and what is their width? It is 4 to 6 meter, and their length, it ranges between your 20 to 200 meter. Okay, and also the detention period of the aeration tank is between 4 to 8 hours for municipal sewages. You can just underline all these values. Okay, so here your the what are the different methods of aeration, okay, like there are how you introduce the air into your aeration tank. So there are different methods, like three methods are there, but two is mentioned here, okay, like one is your diffused air aeration, or also it is known as what, air diffusion, and the other one is your mechanical aeration. Okay, so and one is number three is also what, combination of both one and two. Okay, if air diffusion method and the mechanical aeration method both are combined, so that is also one process, and that is known as your combined aeration. Okay, so now actually okay, we will just discuss two three lines from your this diffused air aeration. Okay, so here you see, like in the diffused air aeration, what it is, what happens in diffused air aeration and what happens in mechanical aeration. You should know the difference between the two. Okay, so in the diffused air aeration, your compressed air is introduced. Okay, compressed air is introduced into the like aeration chamber. Okay, so they under it under a pressure of what, 35 to 70 kilonewton per meter square. So under a pressure of 35 to 70 kilonewton per meter square, your compressed air is introduced into the aeration chamber through what, through diffusion plates or other devices called diffusers. okay, through diffusers. There are some diffusers, or you can say like diffusion plates are there. So with the help of that, your compressed air is introduced into the aeration chamber, okay. And the there is some criteria for selecting a diffuser, okay. So what is the criteria for selecting a diffuser? It is that it should be capable of diffusing air in small bubbles, okay. It should be capable of diffusing air in small bubbles. So why to provide like bubbles? So to provide the greatest like efficiency of aeration, so that the process goes very well, okay. So that's why the diffuser, it should be capable of diffusing air in small bubbles, okay. Now, okay, so so there are here the main thing is here is that your compressed air is like introduced. The other things I think you can read by yourself, like what are the materials of your plates or porous tubes or whatever is present there. So what are the diameter of the plate or diffusers, tube diffusers is there. So all these diameters and dimensions are mentioned here, okay. So you can see here, first I would like to show you the diagram. You see, this is the diagram of your aeration tank, okay. This is an aeration tank using your compressed air. You can see the bubbles. This is a diffuser, okay. This is a diffuser tube, you can see here. This is a diffuser tube, okay. So here you can see the bubbles, okay. So this is a like cross section of your aeration tank using the air diffusion, okay. So this is one L section of a dredge and furrow type of an aeration tank, okay. So here the dimensions are mentioned. You can study dimensions from here, okay. Now the other one is your mechanical aeration, okay. So what is the difference between your air diffusion and the mechanical aeration? So here in the air diffusion method, air diffusion method, we have learned that a lot of compressed air, it gets okay. So since like more of compressed air is required in your air diffusion method, so some percentage like 90 to 95% of the compressed air gets wasted, okay. It gets wasted, and it simply escapes through the tank without giving oxygen to the sewage. So there are many nozzles or holes like that, okay. So what happens, 90 to 95% of the compressed air, it gets wasted without giving the oxygen to the sewage, okay. It escapes through the tank. So now, although it helps in bringing about the required agitation of sewage mixture. So whatever amount of agitation is required in the sewage mixture, that is done. But then also your 90 to 95% of the compressed air, it gets wasted. Okay, so like we don't need any wastage. Okay, so for that, in order to like affect the economy uh, of the tank, okay, so what happens, the atmospheric air, it is brought in contact with the sewage in the mechanical aeration method, okay. So in this in the mechanical aeration method, what happens, the sewage, it is like stirred up, okay. It is stirred up by means of some mechanical devices like paddles. So here paddles are introduced, okay. Paddles are used. Also you can say it is also known as your surface aerators. So in surface aerators, they are used to introduce the air into it from the atmosphere, okay, by continuously changing the surface of sewage by the circulation of sewage from bottom to top. So here some paddles are used. I will show you the diagram. This one, you see, this is a aeration tank, and here these paddles are used, okay. These are paddles. This, you can see this one, these are paddles, okay. There is a motor also provided for rotating the paddles, okay. Then these are the air diffuser plates, okay. So like then Okay, so the only important requirement in this method is to have thorough agitation of the sewage so as to bring it in intimate contact with the atmosphere. So the most important requirement of this mechanical aeration method is that here your thorough agitation is given to the sewage, okay, and the it is brought in contact intimate contact with the atmosphere, okay, and the aeration period it depends upon the what mechanical process adopted for agitation, okay. It generally varies from 6 to 8 hours. So the whole process, the aeration period, it takes between 6 to 8 hours, okay, and the quantity of the return sludge in mechanical aerated aeration tanks is about 25 to 30% of the flow of the sewage, okay. 25 to 30% is your return sludge. So this is no need to go in very much depth about the types of aeration and all, so you should know the difference between the two, okay. So next is your okay, so there are some design considerations. You should consider some design basics of design involved in an activated sludge plant. Okay, so there are some aeration tank loadings. Okay, there are some important terms of which define the loading rates of an activated sludge plant. So you should know the terminologies and the definitions as well. So number one is your like aeration period. Okay. Number one is your aeration period. Number two is your BOD loading per unit volume of aeration tank. So aeration period is also known as your hydraulic retention time, or you can in short you can say it as your HRT. Then BOD loading per unit volume of aeration tank is your volumetric loading. Then food to microorganism ratio, it is also known as like in short it can be given as your FM ratio. Okay, and the number four is your sludge. Okay, so the aeration period or the HRT. So this aeration period, what it says, it gives or it gives the decision of the loading rate. Okay, it gives the decides the loading rate at which like the sewage it is applied to the aeration tank. Okay, so it gives the or it decides the loading rate at which the sewage it is applied to the aeration tank, and like it has a one formula also like this. You can see this one. Detention period is equal to volume of the tank divided by rate of sewage flow in the tank. Okay, and V in P is in meter cube. This is the volume, and Q is in meter cube per day. Okay, so then again they have converted this day into hour, so they have multiplied by 24. So you can say this is the formula for your HRT. Okay, so next is your volumetric BOD loading. So this is another like loading parameter also, you can say empirical loading parameter. And here this volumetric loading, it is defined as what? It is defined as BOD5. Okay, BOD5 means what? BOD at 5 days. Okay, BOD5 load applied per unit volume of the aeration tank. Okay, and this loading it is also known as your organic loading. Clear? So this one is your formula. You can see this one, volumetric BOD loading or organic loading also you can say. So the formula is like mass of BOD applied per day to the aeration tank through influent sewage in gram divided by volume of the aeration tank in meter cube. So this is your mass Q into Y naught divided by V. So what is Y naught? It is your BOD5. Okay, BOD5 of the influent sewage, and it is multiplied by your sewage inflow. That is your how much of sewage is flowing into the aeration tank, and V is the aeration tank volume. So this is the formula for your like volumetric BOD loading. Okay, you have to remember this. Then next is your food to microorganism ratio. Okay, food to microorganism ratio. Thakur, can you hear me? Please mute your mic. Please mute your mic, Thakur. Okay. So food to microorganism ratio. So here this ratio, it is also an important organic loading rate, okay, adopted for an activated sludge process. So it is like it is a BOD loading, okay, with regard to the microbial mass in the system. So here the BOD load is applied to the system in kg or gram is represented as food, and the total microbial suspended solids in the mixed liquor of the aeration tank is represented by M. So basically food by microorganism ratio, it gives your daily BOD load that is applied to the aerator system, okay, divided by total microbial mass in the system. Okay, so this is your formula. So all these things like little your short notes it might come. Okay, short notes or the formulas you should know. Then what is a sludge age? So sludge age, it is defined as your average time for which particles of suspended solids remain under aeration. So your sludge age is also, it is a parameter, okay, related to your FM ratio, it is a parameter. So here it is gives as your the average time that is required for a particle, okay, of suspension solids remain under aeration. Okay, so it also indicates the residence time of biological solids in the system. So this is your sludge age. Okay, then sludge age also it has a one like formula. You see this formula you have to write it down. Okay, sludge age is equal to mass of suspended solids in the system divided by mass of solids leaving the system per day. Okay, the system means your aeration tank. Okay, aeration tank it is saying. Okay.
वो है ना मेरी है ना इसलिए कर रहे हैं ना
Minkim, please mute your mic.
उसके बाद 30 को लेने का फिर वापस अगर
Minkim 13 roll
वापस
number
सबमिट करना
79,
हाँ
please mute
उसको
your
खत्म
mic.
करेगा
You are disturbing me.
सबमिट को फिर यह करना पड़ेगा हाँ हम
Someone please tell him that his mic is continuously it is being on. Okay. Okay, so the meeting will end in 5 minutes. Okay, so advantages and disadvantages of an activated sludge plant, and this one we will discuss in the next class. Okay, there are different advantages and disadvantages of your activated sludge plant, so we will discuss it in the next class. So let me take your attendance. I forgot to bring the attendance sheet, so I will just write it down. Wait. Okay, roll number 51. Roll number 51. 52. 50, 51 is
मैम 51
okay, 52,
प्रेजेंट मैम
51 present, 52,
Present, present.
52 present, okay, 53,
Present, ma'am.
53, 54,
Present, ma'am.
54 present,
मैम 51 is also present मैम
51 I have given, Guneshwar I have given present,
मैम
50,
51 also present oh thank you मैम
Okay, okay. 51, 52, 53, 54. I have given present. Then 55, 55, 56, 57, 58, 59, 60, 61, 62.
61 present, ma'am.
Okay, 62, 63, 64.
Ma'am, 63.
Okay, 64, 65, 66,
Yes, ma'am. 66.
okay, 67, 68,
Yes, ma'am.
67, okay, 68, 68,
Ma'am, 68 is present, ma'am, but he has network issue, ma'am.
okay, okay, then I have given 69, 60, 69, 70,
Present, ma'am. 70.
okay, okay, 71, 72,
I'm 72.
okay, 73,
Present, ma'am, 73.
okay, 74,
62
Present,
present,
ma'am.
ma'am.
74.
74 present. Yes, roll number 62 present.
Present, ma'am.
Yes, ma'am.
Okay. 74 is present and 75.
Present, ma'am.
Okay.
75.
Okay. 76, 77, 78,
Yes,
70,
ma'am.
78. Okay.
Yes, ma'am.
Okay. 79, 80, 81.
Oh, present.
Yes.
I'm present.
79. Okay.
79, ma'am.
Okay. Now you are present. The whole team
79 present, ma'am.
mic was on. 79, 80, 80, 81, 82,
Present, ma'am,
83,
82.
82, 83,
All class are
Present, ma'am, 83.
okay, 84,
Present, ma'am.
okay, 85,
हो गया
85,
name मिल रहा था name उनके name
86,
जाके मांगने थे
नहीं मिल रहा है
87.
हाँ मैम अभी ढूंढ रहे हैं
Present, ma'am. 86
जाके नाम बता दो
present,
अभी
ma'am.
Minkim, please mute your mic.
87 present, ma'am. 86,
Okay,
86 present, ma'am.
okay, just wait. This student is disturbing the whole class. Okay, 84 is present. 85, 85 is present. 86,
Present, ma'am. 86.
okay, 87,
Present, ma'am, 87.
okay, 88,
Yes, ma'am.
89,
present.
okay, 89, 90,
Present, ma'am, 90.
okay, 91, 92,